if I'm sure this comes across your plate a lot. I mean, we're talking about Copeland scroll compressors here mainly. I mean that's sort of what the industry is sort of geared to now. These days is scroll compressors. The technology is quite good. It's actually quite fabulous. Actually, how do we prevent compressor failure? That is the podcast here. There's many ways to mitigate compressor failure, because let me ask you off the bat, how long, let's say everything is perfect, how long should a scroll compressor last in a system if everything is perfect, perfectly
We would
installed?
we would like to see 15, 20 years, 80 to 90% of those compressors running in 15 to 20 years.
15 to 20 years. Now, I have seen compressors run that long. I mean,
Yep.
in different applications, I've seen that. Now, do you think, or do you feel that the introduction of POE oil has changed the game a bit when it comes to install practice? Because that's
Uh,
something that I've brought up numerous times, and it seems
yes.
like back in the day, and the reason I bring this up is because I don't know if you've ever worked on them, like the rectangle ream units.
Yes.
They're
Oh, yeah.
green, and
Yep.
they're
Yep.
still they're like 45 years old, and there's still some in service till this day, right? And those
Exactly.
those weren't scroll compressors, but I mean they had mineral oil. It was lower
Yeah.
pressures with R22.
Yep.
I mean, I think with 410A being higher pressure in mineral oil, it changes the game a bit on how we install and how we service and stuff, right?
Yeah. Yeah. Absolutely. Definitely when POE hit the market, people were using practices that they did previously with mineral oil. And that's when we started running into issues with that POE oil getting moisture inside the systems, turning to acid, getting copper plating, different things like that. It really wreaks havoc inside of our systems.
Cool. So I would really
Definitely.
like to tackle a bunch of these things. I'd like to tackle acid. I'd like to tackle
Yep.
copper plating, seized bearings,
Yep.
fried windings, all that kind of stuff, and in ways that we can really mitigate and avoid these things. So maybe we should start off by. Do you want to start off by talking about how we should be installing systems first, or do you want to talk about the issues that can arise first? It's up to you. What do you think?
How about installing first? Let's
Okay.
talk about that. Yeah.
Yeah, no, I agree. So
I like that.
if we're, let's say we have a, let's keep it very basic and very simple. Okay. So let's say we've got a 2 ton condensing unit, right?
Yep. Yep.
Nothing special, just a single speed 2 ton condensing unit. And we want to install it properly. And
Yep.
we got obviously the matching evaporator too, and the line set and
Yep.
all that.
Yep.
If we want to install it properly, just let's walk through some good install practices to avoid premature failure.
One of the first step, obviously, when we have to size those lines correctly. So our suction and liquid line, if we are not sizing those lines correctly, then we're going to be losing efficiency and capacity. Any system, anything goes wrong inside that system, pretty much, it's going to affect our efficiency and our capacity. The lines will
Mm-hmm.
do that. So we have to make sure that we're cutting it properly. We're using a good sharp cutting wheel. We deburr the pipe. When we are brazing those pipes together, we are using nitrogen, because when we're using nitrogen, it displaces all that oxygen. So we don't have any oxidation inside of our lines. That's going to be really important. Once we're sure that we are leak free, because we're going to have to check to make sure our system is leak free, then we want to charge that system. And I always want to tell people, use whatever the OEM recommends. But as far as Copeland is concerned, we would like you, if it's a blended refrigerant, it needs to go in as a liquid in the liquid form. And when it goes into the system, we want it to go into the liquid line and then bring it around. That high pressure will go into the low pressure because it's evacuated. And we've evacuated that system down to, 500 microns or lower in some cases. So that pressure is going to go from high pressure into the low pressure and then get our system going. But it's
Mm-hmm.
going to be so important to evacuate that system properly. We don't want to be rushing our evacuation system and doing that process, just really, really fast. We want to make sure all the contaminants and all that moisture is out of that system. That's going to
Yeah,
be
and
a
fast,
huge.
fast is like the some of the comments I get online is like purge and roll, baby. You know, there's, well,
Exactly.
I don't know if you've seen him, but the guy online that comes on and does his comedy skits and purge and roll has kind of
Yeah.
adopted
Yeah.
that phrase. But there's actually texts that do that. They still believe
Exactly.
in
Yep.
purge and roll,
Yep.
and that's your quick sort of
Yep.
evacuation.
Yep. Yep.
So let's go back. Let's go back to line sizing for a minute, because I mean, if you're talking about, usually in the manual, it'll tell you like if it within a certain range that the line set that they're giving you with the unit is pretty standard. It can be
Yeah.
used. But if the line set is longer or something like that, if it's beyond what it says, you might need to look at changing the line set a little bit. And one of the things that you can't do, and I've seen done before, is grossly oversize a line set, because then you lose a lot of velocity, right?
Yes.
And the velocity is bringing the oil back to the compressor,
Yeah,
right?
exactly. Yep.
And if you undersize the line set, you can have issues with higher pressures in the system, potential overheating, all that kind of stuff. So
Yes.
I
Yep.
do agree there.
Yep.
Coming back to nitrogen brazing.
Yes.
Now, obviously, it makes a difference. I've brazed two sets of pipes, cut them open,
Yeah.
and seen one has copper oxide and one doesn't. That's there's still people that don't believe in it. Like what message can you give to these people that don't believe in nitrogen brazing?
I would just say try it. Like you just said, do it yourself. And some people, maybe they aren't doing it correctly when they're purging with nitrogen. If they have a pipe and it's wide open, they could be doing a larger pipe, even inch and eighth or quite a bit larger than that. If they have it wide open on the other side, that nitrogen is not going to displace all the oxygen inside that pipe. We have to pinch it down on the other side.
That's
right?
a good point.
So we're not using that much nitrogen. One complaint I always get is, oh, it uses too much nitrogen. I'm not going to do that. Well, it doesn't. If you're doing it correctly and you have the right flow, you don't need pressure. We just need a little bit of flow. We have the correct regulator. We have so many great tools these days. It's hard not to do it right. But still, like you say, people are doing it wrong. But just getting that nitrogen in there is going to be huge for that system, because all that oxide is going to get to everywhere inside of that pipe and fill up screens and eventually get to our compressor and, cause damage in that system and take some life away.
Yeah. And one of the things, I just did a little mini podcast on this, because I have that cutaway Copeland scroll that you guys sent me, which I think is a really cool kit. And as I'm going through the little manual, building it, taking it apart, putting it back together, stuff like that, I'm realizing a couple of things. If you've got that copper oxide in there, and let me go back to 3 pieces in that compressor. One, on that muffler plate, we got 2 relief valves. We got a temperature operated one and a spring loaded one, right? And then we have our floating seal, which also can cause equalization between the 2 sides.
Exactly.
So if we have copper oxide traveling in the oil, right?
Yeah.
And we get copper oxide jammed into the spring or into the floating seal and it can't seat properly, we can start getting a compression ratio that looks odd. We're going to lose efficiency. Our compressor could start overheating over time because we're not, you know what I mean? So
yes, absolutely.
People don't understand and realize these things, and they might change a compressor 3-4 years in. Maybe the TX valve is not plugged. Maybe the orifice is not plugged, but we've gotten through somehow, or it's not fully blocked and it's partially blocked, but we've gotten through somehow. And some of that is in the compressor and it's in the oil, and it's causing like the spring-loaded relief valve not to seat properly because maybe it went off at some point. Who knows, right? Maybe somebody tried to pump down the system, realized they couldn't, right? And that's something else we can talk about. And the copper oxide's getting stuck, and we're not getting that proper seal. And then they're changing out the compressor prematurely and not realizing why they're changing it. And then they get online and they call it a piece of shit. These are the comments that I deal with all the time. So
absolutely.
I wanted to bring that up as one of the factors. What do you think of that?
I really think that people need to see the inside of these compressors. A scroll compressor is not that easy to see inside of it, right?
Exactly. You got to cut it open.
Yes, exactly. And that's not an easy job. You can do it in 10, 15 minutes, but your normal technician is not going to have that time. Now, if they did have downtime, or they had somebody else at their shop that had some time, let's take that thing apart, right? So that's the one thing when you're taking apart a compressor, it does not lie. You can see exactly what happened to that system. So you can see the copper oxide, you can see oil dilution, you can see the overheating, all those things, and you can prevent that from happening to the next compressor instead of saying, yeah, this is a piece of garbage, and I just keep putting in compressors. Well, it's not the compressor problem, it's the system problem.
Yeah, and I've always said, I learned this back in the day, and it was an old boss of mine. He's like, once you replace that compressor, find out why it failed.
Yeah. Yep.
Right. If it's dead and you put it back in, don't just walk away. There could be an issue there. There could be an airflow issue. There could be a plugged orifice. Hopefully, if you're changing the compressor, you're changing the dryer. Yeah. It could be a contactor that's not pulling in properly. You know what I mean? And it's maybe partially single phasing and you're not catching it. There could be a lot of different things. So I mean, my rule of thumb always was when I change a compressor is the dryer goes in, not really a rule of thumb. It's basically like a rule. New dryer and new contactor. It's always
Yeah.
been something that I would do with
Yep.
with a brand new compressor. Some compressors actually, when you go to the supplier, it's actually in their system to just
Yes,
give you a
exactly.
dryer and a contactor with the
Yep.
compressor, right?
Yep.
They've actually updated
And
their system to do that.
yeah, exactly. Single phase, a capacitor, replacing that. Yeah,
Yep, true. For
definitely.
starting components for single phase
Yep.
stuff. Yep,
Yep. Yep.
100%.
Absolutely.
100%. So
Yep.
let's move on. So line set size is important. Brazing
Yep.
with nitrogen is very
Yep.
important. And the other thing that you get, because we're going to move this into evacuation as part of the install, the other
Yeah.
thing that you get when you braze with nitrogen is that you're removing the air already. So when you start your
Yeah.
evacuation process, you
Yeah.
start with less air and moisture and contamination in that pipe, right?
Exactly. Exactly. Yep. Yeah, that's a great point. Yep.
So
And
your evacuation under 500 microns is super important. I mean, on brand new systems, on older systems, sometimes it's difficult because you've got old POE oil in there.
yes.
If you're changing a leaking component or you're fixing a leak or something like that, you've got
Yep.
the POE oil that's absorbed some of the moisture.
Yes.
Sometimes it's difficult in that scenario to get below, but
Yep.
in a brand new system, you should be able to get
Yeah.
below 250, no problem, right?
Exactly. Yeah. And what my rule of thumb when we're evacuating is we want to have the largest diameter pipe and get rid of all of those restrictions and have our pipe as short as, or pipes, or hoses, I should say, as short as possible. So if we can use the larger diameter hoses, that's going to help create that pressure differential to get our pressure down into the 250, 300, whatever microns.
Yeah. And I mean,
Yep.
I've tested it with Schraders in and Schraders out, and the
Yes.
argument
Yep.
always was is you're only as good as the smallest fitting in your system.
Yeah.
Well, you're not, because I've tested it. I've tested it
Yep.
with 1/4 inch hoses. I've tested it with larger
Exactly.
diameter hoses, and the
Yep.
larger diameter hose always wins in a race
Yes.
every
Yeah.
single time.
Exactly. 100%. I recommend when people have downtime again. Doesn't always happen in our industry, but try that. At your shop, hook it up with bigger hoses and smaller hoses, and see how much time you'll save. So
Hmm.
definitely. And we want to
So
make sure that we're getting all that moisture out of that system, doing a decay test, and making sure that system is good and clean.
that's where I was going next is the decay. A lot of techs they'll hit 500 microns on their micron gauge, no matter where it's placed on the system, right?
Yep.
Because a lot of technicians use a micron gauge that's embedded into their digital manifolds,
Yeah.
right?
Yep.
And I
Yep.
don't really like doing that, to be
No.
honest with you.
No. Me
Uh,
neither.
and then once they hit 500 there, they'll open up the valves and slam it in. But what they
Hmm.
don't realize is that if they shut the valves off and isolated the system from, or isolated the pump from the micron gauge, they could potentially see a rise. That
Yes.
rise, even though you're leak free, you could see a
Yes.
rise because you still have
Yep.
contaminants in there. You still have more evacuation to do. So
Yes.
your decay
Absolutely.
test is super important. And for those that don't
Yep.
understand, maybe you should talk about decay and tell us what it is, so those listening that don't know
Yeah.
fully understand.
Yeah. But first of all, so when we're evacuating, so if I'm in an office right now, if I were filling up this office with pressure and I had gauges all over the place in this office and I had 100 pounds of pressure in this, it would be 100 pounds of pressure everywhere in this room, right? Well, now if I'm evacuating this room and I have a big hose in the corner of this room, it could be 500, just like what you said, with the micron gauge closer to that vacuum pump. But on the other side of that room, we could be at 1,500 microns.
Yeah.
So when we're doing that decay test, we're going to get it down to whatever micron level we want. I always check with the OEMs specifically on equipment and stuff. Some might want a little different amount. It could be 400, it could be 250, it could be 500, whatever it is. And then we're going to let it sit there for a period of time. And if our vacuum rate rises and then it goes steady out, it just means that we have moisture still in that system. If it gradually goes up to 760,000 microns, which is
Yeah.
atmospheric pressure, that would mean we have a leak. And hopefully we have that taken care of already, right? But not all the time. Sometimes we're in a hurry and we miss something, right?
Yeah.
So we need to make sure that leak rate is down far enough for that decay test that it's going to hold and we don't have any moisture in that system. So.
And I want to give a bit of a nugget to the techs that are still learning here. If let's say your nitrogen test holds for an hour. Let's say it holds for an hour, but when you do your evacuation and you do your decay lasts for 10 minutes and it's back up to atmosphere. Well, you know your system is most likely leak free. You've got a leak in your evacuation setup, either in
Yes.
your
Yep.
hoses or your seals or your micron gauge or something.
Yep.
So if
Yep.
you know your system is pretty much leak free, but you've got a decay test that goes through the roof, look at your
Mm-hmm.
evacuation setup because there's probably a leak in there. I just wanted to
Yeah.
throw that out there.
Yeah. So many people like, when we have O-rings and stuff, just tightening those fittings so tight. They do not need to be so tight, right? Just hand tighten everything. That
Yeah,
will save.
with new seals, yeah, hand tight, really hand tight is all you need, right?
Yeah. And I always recommend have separate hoses, vacuum rated hoses for evacuation also, right? And
Yeah,
don't use manifold gauge
I've
sets.
heard the reason for that is because if you're using your regular charging hoses, you can have refrigeration or refrigerant kind of absorb into the hose,
Mm-hmm.
and then when you do your decay test, you can have some of that refrigerant actually off gas, and
Yeah.
it looks like you've got
Yeah.
more evacuation to do, or you've got a leak in the
Yes.
system,
Yeah.
but you really don't. You just have
Yeah.
off gassing
Exactly.
from what's absorbed inside the charging hoses.
Yep.
So if you
Yep.
always use a different set of hoses for evacuation only, you
Mm-hmm.
don't get that off gassing of that
Yeah.
absorbed refrigerant,
Yeah.
right?
Yep. Absolutely. Yeah.
Cool.
Definitely.
So I mean, the next thing really is charging. Like a lot of units already have the nameplate charge, it's weighed in, but
Yep.
sometimes you got to add.
Yeah. Yep.
Sometimes you actually have to take out. And I'll give you a
Right.
scenario where I've had to
Exactly.
take out. I built a trainer and it couldn't have the maximum amount of
Mm-hmm.
line set that the manual asked for because it was a trainer. It had to be small
Right.
and
Yep. Yep.
compact.
Yep.
So this thing was going on. It was a heat pump. It was going off on
Mm-hmm.
high pressure, right? Within a few
Yeah.
minutes.
Yeah.
So basically, I had to remove, and it wasn't an exact science. I removed a bit of refrigerant while it was running because I was experimenting too with it.
Sure.
And I had my recovery tank hooked up to the system,
Mm-hmm.
and I would just remove a little bit of refrigerant, open up my manifold, remove a little
Yep.
bit of refrigerant from the high side into my tank,
Yep.
watch it run for a bit, do it for a few more times until it actually was running in the envelope where it needed to run. So
Yep.
you got to be careful of that too. Like, if your line set is too short,
Yes.
you might have to remove
Yes.
refrigerant.
Exactly.
If it's too long, there's usually a way to add refrigerant. There's usually instructions in the manual to do that, right?
Exactly. Yep.
So, I mean, some systems don't even have a weight in charge, though. Some systems, like when I
Mm-hmm.
used to install Liebert equipment back in the day,
Yeah.
they didn't
Exactly.
know how big your line set was. It
Okay.
could be 100 feet, it could be 20 feet, it could be 200 feet. So you had to do
Yep.
your line sizing appropriately. And then when you
Yep.
charged it, you had to follow their charging instructions to add the right amount of refrigerant to that system.
Exactly. Yeah. Absolutely. Definitely.
So that kind of covers the install part. I mean, proper
Yeah.
line sizing,
Yep.
nitrogen brazing, evacuation decay, and refrigerant charge. It's all got to be
Yeah.
correct. And there's a bit of a
Yep.
science to it all, right?
Yeah. Absolutely. It's so important when you're going through. I also recommend once you get the refrigerant in there with the manifold gauge set, before you open up your valves, everything's good, right? Almost ready to turn on the unit. Open up both of your valves so that it is the same pressure and it equalizes throughout the system. So we don't have too much back pressure and we have enough refrigerant in that system to cool down that compressor. Okay? Because these scroll compressors are refrigerant cooled, and we need to make sure that refrigerant is coming back enough mass flow to cool that compressor. Yeah.
Mm-hmm.
So, yeah.
Good point. So there is a label, and I made a post about it recently. There's a label on certain Copeland scroll compressors that basically state if it overheats, it will still, the motor will still run, but it won't pump.
Yes.
Right? Can you
ASTP.
talk about
Yep.
that for a minute?
Absolutely. Yep. So those are commercial compressors, and what happens when they hit 275 degrees, the high pressure goes into the main part body of the compressor, so it equalizes inside of that compressor. And when it's doing that, it's not pressing the scrolls together, so we're not compressing, so it's not doing any work, but the motor's still turning. So if a technician just went to a system, all they would know is that compressor's running. If they put gauges on it, the gauges are equalized, right? But if we were watching it from the beginning, what happens is when it hits that 275, it'll actually start lowering that temperature. The amp draw will go down, so it's protecting that compressor without any other device. So it's a little mechanical bimetal disc inside of that compressor near the scroll set. There's just a little channel that will take that high pressure and bring it right into the low pressure of that compressor. And so it will not make the scroll sets compress anymore. So when it'll lift up a little bit.
So basically, it's a temperature activated device. It's just like
Yes.
a is it like almost like a snap disc, like a bimetal?
Exactly. That's what it is. Yeah. And at 275. Yep.
75 degrees.
Yep.
Okay. The basically you got to let it cool, or
Yes.
you let it cool naturally, or you can get a hose, or you can.
Yeah.
I mean, some
Exactly.
commercial roofs, it's
Well,
almost impossible
yeah.
on a service call to pull a
Exactly.
hose up to it.
Yep.
So I mean,
Yep.
you could let it cool naturally. If it's an emergency
Yep.
situation, you're gonna have to
Yep.
find a way to cool it down
Cool
quickly.
it.
But
Exactly.
you cannot test it again until it's actually cooled and that snap disc is
Exactly.
back
Yep.
in position.
Absolutely. And when I do my trainings all the time, and I explain that whole process, I would say almost every week, somebody or multiple people in my training have said, yeah, we have sent that compressor back for warranty. I did not know that even happened. Because you look at some manufacturers, that sticker that says that on the compressor, it's way behind. So the technician might not be able to see that very easily.
Yeah.
So, but it's very important because we don't, when a compressor is changed, if the technician comes the next day or a different technician to replace that compressor, I always recommend to see if that compressor is going to work. Ohm it out again, not in this case, but if the motor protector tripped or whatever, and see if that compressor runs. So definitely, because a lot of them come back under warranty. So yeah.
Yeah, I'm sure that's a big cost to the company to replace a compressor, and we've got a good one here that we can't do anything with now because you can't sell it to someone used, right?
Yep, exactly.
So yeah,
Yep.
I know,
Yep.
I get that. I get the pain there. So let's move on to some failures, because you've got some show and tell parts that you can show us. And for the audience, guys, just do your best. We'll do our best to describe the parts and what the failure is. I'm going to be putting these out as little segments on social media. So, I mean, if you follow along on Instagram and Facebook and TikTok and LinkedIn and all that, you'll eventually see these parts. But if you're listening to this, just kind of try to visualize as best you can. We'll try to do our best to describe. So which part do you want to start with first, and kind of what the failure might have been with it?
I like this one first. So you can see those little circular pieces inside of here with this.
Let's describe.
Yeah. So I have a scroll set. This is the bottom, the orbiting scroll.
Okay, that's the orbiting scroll. That's the one that's connected to the crankshaft and rotates.
Exactly. So this is the fixed scroll, and this goes right into here. Okay.
Okay. So right now, Jeff, for those guys that can't see, he just held up the fixed scroll and the orbiting scroll, and he put them together so you could see it. So he's going to talk about the little plates or the little scars on the bottom, right?
Yes. So the fixed scroll gets bolted in. It has little sleeve guides that gives it 1 millimeter of lift. So it'll be able to move 1 millimeter up. Okay. So that's our axial compliance. This goes, the scroll set, the flanks themselves would be facing up into the fixed scroll. And then it gets connected by an Oldham coupling, which is just an aluminum coupling that fits into some grooves. And it takes that rotating motion. Most of our compressors are going to be running at 3,500 RPM, right? And it's going to take that rotating motion into an orbiting motion, okay? So it doesn't just keep turning, it orbits inside there. When we have, so in this case, we would have oil dilution, okay? And that could be from maybe a little bit of floodback, where if we lose superheat in our system, okay? Maybe we had an air filter plugged up completely solid, something like that. That would cause that galling, or just a lack of oil. Or it could be overheating, actually. If it overheated, would cause oil dilution. And these little marks are called galling. And you can see the little circles, and that's where it is actually orbiting on itself. We shouldn't actually have metal on metal ever, right? We always want to have lubrication in between these parts. The one thing that is unique with our scroll sets, there's only metal parts in here, right? And you can actually see the galling if you're.
Well, you can see the galling inside the scroll as well as on the back of it too. And just so I can describe it for the audience, it looks almost like someone has taken a grinder and sort of made grinding marks on it. That's kind of what it looks like.
Yep, exactly. So we do not want to see that. It should look similar to this. This is a little smaller scroll set.
Nice smooth finish to it.
Yeah, almost like brand new. And this came out of a compressor. I don't know how old this one was, but yeah. So you should not be able to see any marks in there.
So the galling could be caused by overheating, you said, or lack of oil return?
Yep. So we have overheating, which will cause oil dilution. Flood back, which will cause oil dilution. Flood back
kind of washes away the oil, right?
Washes away the oil. Yep, yeah. Exactly. So that's where we're going to, if we had a lack of oil, like we had a piping problem, maybe we didn't have traps or something like that, then you'd see every one of the bearing surfaces in a scroll compressor would be damaged. Okay. If it's normally with a refrigerant cooled compressor, like a scroll compressor, we're going to see the damage if it's a flooded start. That's usually what kills them. It's going to be progressive wear. So you're going to see, so this is the newer, they could both be actually the same year. I have no idea, but there's a bearing in here, a bearing sleeve. And then this is the top drive bearing. And there's a piece that fits inside of there. And then this bearing piece fits right on top of the crankshaft. Okay. So that is the last piece that gets lubricated from the oil on the bottom of the compressor. And when we have a flooded start, when the compressor's been off for a long time or something like that, that's when we're going to have damage in this bearing. Okay. And this one isn't too bad, but there is a little bit of damage. It's discolored.
Yeah, you can definitely see that galling. It just puts a
oh man, yeah.
It just puts a really reflective shine to it, right?
Yep. Because it's metal on metal, and it shouldn't be like that. Yep.
Now let me ask you this. This is just, I'm just going to take a side road for a minute. We'll come back. A single speed scroll compressor, how does the oil get through the crankshaft into the scroll set and all that?
Awesome. That's a great question. So if you were looking at the crankshaft, so the rotor is on the crankshaft. Right on the bottom, there's a hole, a pretty good size hole. And there's this little flinger on the bottom. It looks like 2 fingers, actually. Yep. So when the crankshaft is running the correct direction, right? And we're running at 3,500 RPM, the hole in the crankshaft is a little bit off center, and it uses centrifugal force to go all the way to the top. And there's a little journal for the main bearing in the middle, and then the drive bearing on top. And it goes right through the top of the shaft. So it goes all the way up, and then centrifugal force is forcing that up. The only one that we are not lubricating that way would be our BPM variable speed compressors that need a positive displacement pump. Yes.
Yeah, it's good. I was going to say that's got a positive displacement oil pump, which is a very cool feature.
Yep.
Okay.
That's how they get lubricated through the shaft.
I just wanted to, because you brought up oil and oil wash and all that, but I just wanted to figure out how on this single speed compressor we're getting the oil up. So the flingers, the right direction, and getting up to proper speed is going to bring that oil to all the moving parts. Okay.
Exactly.
Cool.
Yep.
So what you got next then for us?
So when we look at the fixed scroll, in the fixed scroll, this is another example of a fixed scroll. This one's a little smaller. We have the floating seal that sits right on top of that fixed scroll there. That floating seal will press up, and this is called a muffler plate. So if you can envision a scroll compressor, the top maybe quarter of it is maybe a little less than that is the discharge pressure. So that's the high pressure, right? And in there is welded the muffler plate. If you actually remove the muffler plate, you'd see there's like a disc inside there, and the floating seal presses up against that disc. Okay. So when this is on here, if we're looking at a scroll that is not running in the scroll set, see if I can see one in one. It's too hard to see. There's a tiny little hole. So if the compressor's not running, that high pressure on top of the muffler plate is going to come down through the scroll set into that tiny little hole into the bottom portion of the compressor. So it's going to equalize. All the pressures are equalizing. So our single phase compressors do not need starting components unless an OEM wants them in there, right? But most of them, they're not going to need it because it's not working against any pressure to start again. Okay. When that compressor turns off, that floating seal is going to come down a little bit, and it's not a lot, but now the high pressure on top of that is pushed down. When it starts, we have pressure coming up through that little hole, and it pushes that floating seal really tight. Now we have a separation in pressure. So it discharges out the center of the fixed scroll, and all the discharge gas is going to be on top of the muffler plate. So that creates the difference. So below the muffler plate is all going to be low pressure. Above the muffler plate is going to be the high pressure. That floating seal is very important, and it will trip. So it'll go off balance generally So we were talking about compression ratio a little bit earlier. When we're looking at compression ratio, so if we're used to dealing with pounds per square inch, we need to get that to atmospheric pressure. So we can use 14.7. Depends on our atmosphere where we are. For easy math, I usually say 15. So we're going to take our discharge pressure plus 15, our suction pressure plus 15, and then we're going to divide that, and it's always going to be to 1. So discharge divided by our suction pressure, we're going to be something to 1.
Yeah,
for
it's
air
usually
conditioning,
around three to 1.
3
right?
to 1. Yep.
Yeah.
So for medium temp, 5 to 1. For low temp, 10 to 1. Okay. Now this will go off balance for air conditioning if it hits higher than 11 to 1. Okay. And it'll go off balance. When it's off balance, or if we had, like we were talking about earlier, if we had something in our system and this does not seal properly, we're not going to be able to pressurize and do our whole compression process, right? Or in the refrigeration world, if it gets higher than 26 to 1, then it goes off balance. So the scroll for the refrigeration is a little different than air conditioning scrolls. They're a little thicker to be able to withstand that higher pressure and temperature for that compression ratio.
Yeah, it's very important to understand all of this. I mean,
Yeah.
there's people out there that don't really care. It's like, okay,
Oh, yeah.
here's a sealed box. I'm throwing it in, brazing it up. Okay, I'm out. But there's people that really want to deep
Yeah.
dive and understand this kind of
Yes.
stuff. So I really appreciate these conversations. So
Yeah.
the floating seal is an integral part of that machine
Yes.
because, like you said, it keeps the seal of the discharge, so we're not equalizing through.
Yep.
And it also helps keeps the two scrolls sort of in that compliance with each
yes,
other, right? Pushes them down and
exactly.
makes that pumping action happen, right?
Yes, exactly. Absolutely.
Cool. So you got a ton of other stuff there that we can go through too, right?
So I also have from a semi-hermetic a crankshaft, and when we're looking at a semi-hermetic compressors, we still make quite a few semi-hermetic compressors, right? In Rushville, Indiana. But there's in the motor section we have 2 bearings, and they're pretty close together. When we have a lack of oil, so this could be, say, we had a piping problem or something like that, our bearings are going to come out of that shell of that compressor and seize to the crankshaft itself. So I always tell people if you're working on a system that has a semi-hermetic compressor and the compressor failed, these are easy to take apart, right? So we can get that pressure out of that system. If we're working on a rack or whatever, we can isolate that compressor with no pressure in there. Mm-hmm. In 10 to 15 minutes, we could take the head off. We can look at the valve plate. We could take the oil pump off. And then from the oil pump, you're going to be able to see the end of the crankshaft, okay? Where the pistons and the connecting rods are. And then you'll be able to hold on to that end and then lift it up and down. I say we're shaking hands with the crankshaft. If it has bearings that are seized to this crankshaft, you'll be able to lift that up and down, okay? And I see this quite a bit. So, because I mean, every week pretty much I'm somewhere else doing classes and we take apart a lot of compressors.
Yeah. So, I mean, one of the big ones is copper plating, and you don't have any examples to show, but
No,
I do have an image that you sent me that I can put inset in the video here.
Yep.
Now, copper plating, explain what copper plating is.
So if we're looking at a system, and it could be a system that we did not evacuate that system all the way, so it has some moisture still in that system, eventually that moisture with that POE oil is going to turn to acid. And the acid is going to etch away any copper surface. It could be our pipes, it could be our coils, it could be our windings, anywhere in that system. And then with heat and those minerals coming around inside that system, it is going to adhere to the hottest spot on that system. So if it's a scroll, you will still see copper colored. I just happen to not have any with me today. But you'll see copper coloring in there. And I just did a class in Cleveland this spring, and we took apart the compressor, and literally the cylinder walls looked like they were copper. The pistons were copper colored. That was probably one of the worst I've ever seen. Mm-hmm. But almost every compressor now that we take apart, somewhere in it, there's copper plating. So that means to me that those systems, either they have a leak or they're not evacuating those systems properly in the beginning.
Yeah. So copper plating, it's a problem because the copper, even ever so slightly, it builds on the parts and it takes our clearance and it kills our clearances, and they start rubbing and touching each other. And it doesn't matter how much oil you have, if they're already
Exactly.
touching each other because they're
Yep.
built up too much, then
Yep.
they're going to hit each other,
Yep.
cause that grinding sort of stuff
Yep.
we saw, and eventually even
Exactly. Yeah.
seize up, right?
Yeah. Yeah. So we're going to have that extra friction. So we're going to have extra heat, and our current is going to go up on that system. So it's really going to affect that system. So most problems in our systems take time to kill that compressor, right? Most of them except for slugging. So that's another story, right?
Yeah, slugging's like an instant blow up.
Yeah, that'll kill it. You'll
Yeah.
know it if it's slugged. Yeah. But all the other ones take time. It's not, I could overheat it today. Next week, it could be really hot where we are, and it's going to affect that system. It takes a little bit of time, but eventually it's going to take life. Every time something happens, it's going to take life out of our compressor. And that's the thing that we do not want to do. We want to give that compressor a good long life out there.
Yeah, so it's a slow death. I mean,
Yeah.
bad install practices, and that's why you get a lot of technicians or installers saying, "I've been doing it this way for 30
Yeah.
years and never had a
Yep.
problem."
Yep.
That's because most of the time the problem occurs like 6 or 7 years later, and they're long gone.
They're
Right? They're
gone.
long gone.
They have no idea. Exactly.
Yeah, they have no
Yep.
idea.
They
So
have
I
no
mean,
idea what happened. Exactly.
exactly, and it's always somebody that goes back to do the service that
Yep.
encounters the problems
Yep.
that the installer did not do.
Yep.
And there's probably installers listening to this think that we're full of shit, but I
Exactly.
trust you. I trust you. We're not, because these things have
Yes,
all
exactly.
been proven
Oh,
through
absolutely.
taking apart compressors and looking at the inside of them.
Yes. Yeah. And I mean, we do this to our own compressors in our lab. I mean, in Sydney, Ohio, we have a beautiful lab set up here, and we beat the crap out of these compressors. It's amazing. I can't believe what they do to these compressors to see. I mean, they just throw liquid in there. They want to see what happens to these compressors and when they fail. Right. So on that same note, when we look at things, now all of a sudden we're adding A2Ls in the system.
Mm-hmm.
We have new refrigerants coming, right? So these new refrigerants are a little different. We want to have, because we have our standards, how we test our compressors, right? We're not just going to say, okay, this compressor, I'm going to put any refrigerant in there. It doesn't matter. We're going to test our compressors differently. So for example, we have a YA compressor. That's going to be for 454B only. We have a Y compressor, scroll compressor. That's going to be for R32 only. I can't put any other gas in there. It's only UL rated for those refrigerants. So we want to know when we're doing our testing in our labs that compressor is going to have a good long life, just like all of our other compressors did. So that's a really important thing, thinking about the future here, because that's coming very soon. There's some out here already. So these different compressors that we're sending out to these OEMs are a little different. When we look in our testing, the R454B is about 15 degrees warmer, runs hotter, okay? And then R32, then R410. R32 is about 30 degrees hotter. And we actually, in our YP compressor, have a different oil, a higher viscosity oil. So it's a little different. We got to think about that too. So.
Yeah, a lot of changes in this industry in the last few years, and it's very difficult to keep up. I find it hard. I find it super hard to keep up, and I'm constantly having conversations
And you're in it. Yeah.
with people like you, and I'm having a hard time keeping up with everything. So
Yeah.
I
For your
really
average
appreciate
technician, yeah.
Yeah, so I really
It's crazy.
appreciate having these types of conversations, because it keeps me up to date, and the audience gets to learn along with myself. But, I mean, I think for now we'll probably, and unless you have another part to show us, do you have any other parts, or
That's pretty much it right now.
pretty much it for now?
Yeah.
Okay, so I think for now we covered install practices. We covered some of the parts and some of the things that can happen if you don't follow these install practices. But I'd like to get you back on to talk about A2Ls, variable speed, two-stage compressors, all that kind of stuff, because it's out there now, but it's going to be, I think, variable speed compressors are going to be they're going to be a standard very, very soon.
Yes,
right? So
exactly.
So I'd like to get you back on to talk about that in the near future, and we'll call this one for now, because I think we got what we needed to get out of it for sure.
Awesome. Thanks, Gary.
Yeah, Jeff, thank you very much. I appreciate your time today.
Yeah, awesome. Had a great time.